Hi everyone, my name is Kazi Anikamet and my N number is N154605997. Tonight I'll be doing homework number 3, problem number 7. So first, I've already done it, and what I'm going to do is I'm going to walk you guys through each step and explain why I did those certain steps and why and how. So first, let's read the problem first. So it's an LTS system has zeros at Z1, which is 1/3, Z2 equals 3, and a double pole, or 2 poles at Z equals 0. So if the DC gain is to be 1.0, find your H of Z. So we can write this problem as H of Z, in terms of H of Z equals K, which is my gain, Z minus 1/3, and Z minus 3, which are my two zeros, divided by Z squared, which, because I have a double pole at Z equals 0. Now the DC gain, to find the DC gain, let's solve for this K. So now let's solve for K. Now if we replace the Z's by 1, since our DC gain we want it to be 1, we solve for it, we do some algebra, and by solving for it, we get that it equals to this whole thing will equal to negative 4/3 multiplied by K, which is right there, equals to 1. Why equals to 1? Because we have said that H of Z equals K times this whole thing, and we found the whole algebra to be negative 4/3 multiplied that of K equals to H of Z. And we've said that we're going to replace Z with 1, so this will become 1. Now we just multiply negative 3/4 to both sides, and we get K equals to B when this goes to the other side to negative 3/4, just right here. Now, and so our H of Z, if we replace the K with negative 3/4, we get negative 3/4 times Z minus 1/3 times Z minus 3 divided by Z squared. Now for the second part, we are told that find the impulse response of the stable inverse system G of Z, of the same system but inverse of the system, which is G of Z. So we get negative 4/3 instead of that, and we get Z squared on the top divided by Z minus 1/3 times Z minus 3. Now we're gonna divide both sides by Z because we're gonna get that Z by itself. So when we do that, we get negative 4/3 multiplied by Z minus 1/3 times Z minus 3. Now the next page, we see that now with this I already had written in the other page, so we can set this equal to, in terms of two constant coefficients, C1 divided by this first denominator plus C2 divided by the second denominator. To find the numerators on each terms, what we can do with a simple method, we can, for C1, we can just find C1, we can do is negative 4/3, which is that coefficient in the front, the constant in the first, multiply that by Z divided by Z minus 3, since we are finding C1, and we can set Z equals to 1/3. Why? Because if we do Z minus 1/3 equals to 0, we will get Z equals positive 1/3. So that's what we're going to set it equal to. When we solve for it, we get this, and we get 1/6. Simple algebra. Exact same procedure for the second one. For C2, we'll have the same thing, negative 4/3. Z divided by, now instead of Z minus C, we're going to have the first the denominator of the first term, Z minus 1/3. And for Z, this value, we're going to set it equal to 3. When you solve for it, we get 3 divided by 2. So to write G of Z in terms of the new coefficients, we can write 1/6, which is C1 times Z minus Z 1/3, just right there, and minus 3 divided by 2 times Z divided by minus 3, Z minus 3. Now to find the stability, the ROC will have to be within these two poles. So that would be 1/3. It has to be, the Z absolute value of Z will have to be in between 1/3, just right there, and smaller than 3, just right there. So our impulse response, we can rewrite it as G of n is 1/6. This whole thing will become just 1/3 to the power of n, un, plus 3 seconds, and this whole thing will be 3 to the power of n, u, shifted, inverse, negative n, shifted by 1. Thank you.